Welcome to the Missoula National Weather Service Forecast Office 2022-2023 La Niña Winter Briefing. This is meteorologist Dave Noble. I'd like to give thanks to our climate team here at the office, Bob Nestor, Travis Booth, and Brian Conlon, and also to warning coordination meteorologist Marty Whitmore and forecaster Jeff Kitzmiller. Here's the plan for this presentation. I'll start with the main points for the upcoming winter, then show you the current state of the ocean, what a typical La Niña pattern looks like. We'll look at what happened last year, and then discuss the current drought conditions. We'll delve into the November forecast, La Niña metrics including new probabilities, monthly surface temperature departures for select La Niñas, and then sum things up on slides 24 and 25. After that, we'll look at some of the impacts that occurred in some of the triple dip La Niñas, and then look at individual station graphs of snow, temps, and precip. And to finish it off, we'll do an impact review of last winter season. Currently, La Niña conditions are ongoing. There is a 75% chance of La Niña conditions lasting through the northern hemispheric winter, which is December, January, February 2022 to 2023. This will be the third consecutive winter season where La Niña conditions were present, something we like to call a triple dip La Niña. Remember last year we called the second La Niña a back-to-back La Niña. There are not enough triple dip La Niña winters in the past 120 years to glean any good correlations. Northern Rocky La Niña winters can be snowier, while temperatures can go both cooler or milder. Here's the Climate Prediction Center winter outlook for December, January, February for the Northern Rockies. It's calling for a 40 to 50% confidence towards colder than average temperatures north of Missoula, 33 to 40% confidence towards colder than average temperatures from Grangeville to Salmon and Butte, and a 40 to 50% confidence towards wetter than average. Let's compare the current ocean temperature departure from average, top left, to last year, top right. They are different, especially with warmer waters across the Northeast Pacific this year, and it kind of looks similar to October 2020 in the bottom left. This is showing the recent subsurface temperature departure from average along the equatorial Pacific. The gray line is where the date line is located. You can see the area of cooler than average subsurface water temperatures east of the date line, and that is a La Niña pattern. Here is the latest ensemble forecast of the INSO sea surface temperature anomaly going into next year. INSO is an acronym that stands for El Niño Southern Oscillation. There is a forecast dip towards La Niña this winter, negative values, and potentially moderate in strength, then rise towards neutral INSO conditions by spring of 2023. Here is the general La Niña jet stream structure across North America, a blocking ridge over the Northeast Pacific with frequent low pressure systems diving southeastwards toward the Northern Rockies with cooler and wetter conditions possible. Sometimes the jet stream can dip southwards towards Nevada and Colorado and therefore draw cold Arctic air masses southwards over our region. And sometimes the blocking high pressure can actually have an atmospheric river moving around the clockwise moving wind, bringing warmer and milder conditions to the region, potentially giving heavy mountain snow, but then you have possible rain in the valleys, which could lead to freezing rain and strong gusty winds. The latest run of the long-range model CFS V2 is forecasting near average temperatures across northwest Montana and above average from Lemhi County to southwest Montana. It is also depicting a wetter winter across the northern Rockies. During the last winter season, which was a back-to-back La Niña or second La Niña in a row, the temperatures across north central Idaho and western Montana were generally above average, as seen as the yellow colors. But there were some places that saw slightly cooler, shown as the light blue colors. The precipitation was generally 75 to 125% of average, as seen in the yellow and green colors. Now remember, these maps portray the period of the northern hemispheric winter, which is from December through February. This doesn't capture all the snow that fell before December and also after February, especially in the mountains. Here is a plot of what the percent of average snow water equivalent looked like in the mountain basins on April 1st of each La Niña year. It essentially tells us how much water is in the snowpack. Last season is the top left image. Notice that even though much of the north central Idaho and southwest Montana areas had 70 to 89% of average, that's shown in yellow, and portions of northwest Montana were in the light green, 90 to 109%, much of the heavier snow didn't arrive until after April 1st, going into the late spring of 2022. So it was kind of a timing issue here, and by June 1st, the South Fork of the Clearwater in Idaho had 332% of average, and the Bitterroot Basin had 165% of average. So this translated to a positive water supply for irrigation purposes for like ranchers and farmers. The current drought monitor places portions of north central Idaho and western Montana in moderate drought conditions and severe drought conditions in Lemhi County, Idaho. The drought outlook through January of 2023 shows much of the northern Rockies experiencing the removal of drought conditions. While the areas from Lemhi County to Butte, the drought could remain but improve a little bit. The Climate Prediction Center Northern Rockies forecast for November 2022 calls for equal chances for above or below average temperatures and up to a 50% probability for above average precipitation. This image, created by Brian Bretschneider, depicts the number of times that La Niña winter seasons going back to 1925 were wetter than average. For much of our region, there were 16 to 20 La Niñas that were wetter. That number increases to 21 to 25 wet La Niñas from central Idaho County east towards the Bitterroot Mountains and mountains of Granite, Deer Lodge, and Powell counties. Here's another image created by Brian Bretschneider that depicts the number of times that La Niña winter seasons going back to 1925 were milder than average. 16 to 20 La Niñas were milder as shown in the yellow color, 12 to 15 times were milder along the divide, gray color, and 7 to 11 La Niñas were milder in the mountains shown by the aqua blue color. One impression that I get from this map is the lower number of milder La Niña winters along and east of the divide, which can be connected to Arctic intrusions. In the next two slides, we're going to provide relatively new statistical information that we calculated using the National Weather Service's local climate analysis tool. It can help us give information whether or not climate variables have any correlation with global atmospheric oscillations, such as El Niños or La Niñas. These graphs give us a picture of how snowfall is correlated. The left three columns, or what we call bins, relate to La Niña. The middle three bins are for neutral ENSO years, and the right three columns relate to El Niño winter seasons. And the left bin signifies below average snowfall, the middle bin signifies near average, and the green bin signifies above average. For Kalispell, there is a 57% probability that snowfall could be near average. So the snowfall in this bin, the middle bin, ranges from 28 to 39.5 inches. Keep in mind that the official 1991 to 2020 snowfall sum for the months of December, January, and February for Kalispell is 38 inches. Also to note, the middle column contains a bold border which signifies at least 90% statistical significance. Basically, this means that it's very correlated with La Niñas and rather than chance. Also, there's at least a 90% statistical significance for less snowy for Kalispell, that 4%. And just to cover our bases, there is 39% chance for above average snowfall. For Missoula, there is a statistically significant 48% probability that snowfall could be above average. This column represents snowfall greater than 33 inches for this 3-month period. The climatological average for Missoula is exactly 30 inches. So there's a 39% chance that Missoula could end up with near average snowfall and a 13% probability for below average. I'm sure the previous graphic probably made some of you quite dizzy, so instead of showing all the distribution graphs, I put the probabilities in tables. The probabilities that are emboldened means that those values have at least 90% statistical significance. The higher this statistical significance, the better correlation there is with La Niña, and the lower this statistical significance, the more likely the percentage was a result of chance. Overall, the probabilities lean towards above average snowfall for most of the stations, except for both Kalispell and Pierce, where the probabilities also highlight near average snowfall. Notice the high statistical significance for the very low probabilities of below average snowfall for Kalispell, Huron, Missoula, Seeley Lake, Pierce, Grangeville, and Salmon. It appears that there's a strong correlation here that these stations are much less likely to get lower than average snowfall during La Niña winters. Last winter, the snow probabilities seemed to lean correctly for Kalispell, West Glacier, Huron, Missoula, and north central Idaho. The 77 inches that fell at Seeley Lake was 12.8 inches below the official average, but it's still within the range of the middle bin, or what we're calling near average, so it was in that lower 35% probability. Now let's look at average temperatures. When looking at all the La Niña since 1950, the leaning is towards below average temperatures. But notice the temperature departures from last winter. Just because the probability leans one way, it does not mean it will occur. Missoula last winter saw average temperatures right at average. So that seemingly lower 30% probability became a reality. Butte saw a slightly milder winter, and the 22% probability became a reality. Just keep in mind that though stations may be milder than average, it's still cold. Butte's winter average last season was 22 degrees. Seeley Lake saw a degree above average, and the probability for milder is only 9%. We don't have a co-op station in Grangeville, but our Cottonwood co-op reported 2 degrees below average temperature for last winter. The following 5 slides depict monthly surface temperature departure from average, or what we call anomalies, for a few select La Niñas. The most recent La Niñas are in the top right, so November 2021 and 2020. Then you have 1971 and 1999 in the top left. The triple dip La Niñas of 75, 76, 2000, 2001 in the bottom left, and triple dip 1917, 1918 will be in the lower right. Here we see quite the variability in different La Niñas for November. And notice last year, top right, how mild it was. Here are the December temperature anomalies. December 2021 was a very active month with a cool anomaly to the north. Look right below it, the December 1917. It was warm, but you could see there was a lot colder air east of the divide, and this is a good temperature configuration for a lot of snow. Kalispell that month received 27 inches, while a station near Columbia Falls received 44 inches. That was just for the month of December. 13 inches at Missoula and Butte, and then 19 inches in Cottonwood, Idaho. Here are the January temperature anomalies. Lots of variability. February temperature anomalies. When you average all the February La Niñas together, the anomaly leans towards the colder side. But look at that outlier, February 2000. It was on the milder side of average. And lastly, here's March temperature anomalies, and the last few have been milder. So in summary, La Niña conditions continue, and there's a 75% chance that it will continue through February of 2023. There's a 40 to 50% chance for leaning colder north of Missoula, 33 to 40% chance leaning colder from Grangeville to Salmon to Butte. For precipitation, there's a 40 to 50% chance towards wetter than average. The higher probability for more snow is in the mountains. Temperature swings are expected, so we may have a cold period, and then all of a sudden it warms up in the 40s, yanking back and forth. Cold, warm, cold, warm. This will be the third La Niña winter or triple dip, but there are no correlations to really glean from to project into this winter. Here are some resources for you. If you want to look at the Climate Prediction Center Winter Outlook video, you can look at CPC's ENSO blog, has some interesting posts on there. Now we're in the part of the presentation where the following slides are not the main points, but for more fun information. This image, created by Brian Bretschneider, depicts what the temperature departures were for the previous triple dip La Niñas of 1910, 1911, top left, 1917, 1918, top right, 75, 76, bottom left, and 2000, 2001, bottom right. The more recent triple dips were very different, especially east of the divide. In our region, generally it was milder, especially towards north central Idaho. This image depicts the precipitation departure from the triple dip La Niñas. Both the winters of 75, 76 and 1917, 1918 had greater than 100% of average. Here are some weather impacts from the last 2 triple dip La Niñas. This is just for fun, and I'm not inferring that our upcoming season is going to be similar. The first storm cycle arrived by the second week of December of 2000, and the right image shows the gusty Hellgate winds from an Arctic blast in February of 2001. The triple dip La Niña of 75-76 had its first storm cycle start just before Thanksgiving, and it lasted all the way into early December. An interesting thing to note is that there's some indications that a strong typhoon, Typhoon June or Rosing, recurved northeast of Japan in mid-November of 1975, which played a part in wiggling the jet stream to allow for the Arctic air to shift down here. During this event, an impressive atmospheric river tracked over the Arctic air in place and brought heavy snow that changed to rain in some locations. Check that out. Seeley Lake received 46 inches of snow just in that small period. This first storm cycle also impacted Camas Prairie, Idaho, with a blizzard that shut down Highway 95 between Whitebird and to west of Grangeville. There were many stuck travelers that filled up motel rooms, private homes, churches, and schools. Does this sound familiar? We had a similar blizzard that shut down Highway 95 on the first 3 days of this year, January of 2022. In the following 17 slides, we'll compare last year's snowfall, temperature, and precip to other La Niñas at individual stations across north central Idaho and western Montana. For the following snow graphs, we wanted to include more of the season, so we've included October through April. This helps to include some of those fringe storms like the Arctic that occurred in October of 2020. The temperature graphs will stay the same and show data from November through March. The climate station that we use for Kalispell is located at the Glacier Park International Airport. The last 2 seasons were a little below average, coming in at 51 inches 2020 to 21 and 38 inches in 2021 to 2022. The triple dip La Niña 75-76 was snowier at 57 inches. Though the triple dip 2000-2001 season had no data, nearby stations would suggest that it was snowier too. West Glacier snowfall was above average last winter at 119 inches. The 75-76 winter had 136 inches, or 11 feet, and the 2000-2001 triple dip had close to 10 feet of snow. If you look at the moderately strong La Niñas, 4 out of 6 were snowier. Here are some other snowfall totals from various co-op and Kokora stations surrounding the Flathead Valley. The top 2 left seasons were the triple dip La Niñas, 57 inches and 75-76. While snowfall was missing at the airport, you can see 5 feet of snow fell at both Whitefish and Creston in 2000-2001. Last season, in the lower right, the official station at the airport only came in at 38 inches, while the Kokora station northeast of Creston reported 46 inches. And a Kokora's observer 2.5 miles west-northwest of Kalispell reported around 57 inches. For Missoula, last season came in short at 38 inches. Of the 6 moderate events going back to 1950, 3 were above normal and 3 were below normal. The triple dip La Niña 75-76 had 44.8 inches above average, while 2000-2001 had 42.7 inches. Here are examples of snowfall from other stations around north central Idaho to southwest Montana in the recent years. So the bottom 2 are the last 2 years, and the last triple dip La Niñas are in the top left. And we have the snowy season of 2017-2018 in the top right. For Orofino, Idaho last winter, it was snowier than average at 28.6 inches. The Woodland Kokora's observer received 74.9 inches. The triple dip 2000-2001 was below average at 15.8 inches. Also notice how the Woodland station picked up 81.6 inches in 2017-2018, while Orofino only had 15 inches. There was plenty of precipitation that winter, and I think it was just the snow level just happened to be just above Orofino more often than not. For Salmon, Idaho, last winter they received 32.5 inches of snow, which was 10.5 inches higher than average. 4 out of the 5 moderately strong La Niñas had above average snowfall in Salmon. The following average temperature graphs are sorted by La Niña strength rather than chronological. So for average temperatures in Kalispell, the last 2 La Niña November through March have been milder than average, shown in the middle. Similar to Missoula. Looking at moderate La Niñas alone, Kalispell saw 3 out of 6 that were milder. For average temperatures in Missoula, it appears that more often than not, there are more warmer than normal seasons during moderate and strong La Niñas. Just like we mentioned about snowfall, so in the last 2 seasons for Missoula, they were above average. If you look at the 6 moderate La Niñas, 4 out of 6 were milder. For Butte, Montana, the average temperature last winter was above average. 4 out of 6 moderately strong La Niñas have been milder. For Orofino, the average temperature last winter was slightly above average. 3 out of the 5 moderately strong La Niñas were below average. For Salmon, Idaho, last year was right around average. And when you look at the 3 out of 5 moderately strong La Niñas were near to above average. For Kalispell precipitation, out of the 6 moderate La Niñas, 3 of them had above normal precipitation, 1955, 95, and 2021, and 3 of them had below normal precipitation, 1970, 2011, and 2020. For Missoula precipitation for the months of November through March, out of the 6 moderate La Niñas, 2 of them had above average precipitation, 1955 and 1995, and 4 of them had below normal precipitation, 1970, 2011, 2020, and 2021. For Butte precipitation, out of the 6 moderate La Niñas, the most recent 3 were below average. For Orofino precipitation, out of the 5 moderate La Niñas with data, 3 were above average, including last year, and 2 were below average. For salmon precipitation, the 2.18 inches last year fell short of the average. 3 out of the 5 moderately strong La Niñas were drier than average. All right, let's look at last season, the impacts. November 2021 was warmer than average with near to above average precipitation. There was a high wind event that brought damage to western Montana on the 15th, snow bands on the 16th, and a heavy snow in north central Idaho area, including Orofino and Woodland, on the 23rd. December was a busy month, generally milder than average, but it was snowy, except it was drier from Salmon to Butte. We had high wind, freezing rain, heavy snow, flash freezes, and 3 Arctic intrusions. And drifting snow closed US 95 from Whitebird Hill to Cottonwood on the 30th. Notice how Pierce received close to 54 inches that month, and West Glacier was very similar, 55 inches. One of the biggest storms during the La Niña winter of 2021-2022 was an overrunning snow event January 6 and 7. An Arctic intrusion coincided with an atmospheric river. So we had hazardous travel, avalanches, including west of Saltese, Montana, I-90, east of Bonner on Highway 200, tree damage, road closures, power outages, and icy roads from freezing rain. 18.5 inches of snow fell at Troy, even 10 inches at Riggins, and over 2 feet in the mountains. US 12 west of Lolo Pass was closed for 3 days due to avalanche risk, and it was estimated that 150 trees fell due to the weight of the snow along the highway, that they were still cleaning up this summer. A large avalanche occurred at milepost 136 on US 12, pictured here. Another impactful storm was the severe drifting and blowing snow that closed US 95 on New Year's Day through the 3rd in the Camas Prairie, Idaho. Freezing rain caused slick conditions during January 11th and 12th, and also on the 18th. February 2022 saw generally colder than average and drier than average conditions. There were 2 Arctic intrusions that brought wintry impacts generally across northwest Montana. The Arctic wind brought wind chill temperatures as low as 35 below zero. March 2022 started mild, then a brief cold spell from an Arctic air mass, then it finished up warm. Overall, it was a milder than average month, drier than average except for northwest Montana. Notice Libby Dam reported 2.94 inches of precipitation, mainly rain. West Glacier saw 3.92 inches, which was 1.34 above average, and they only had 5 inches of snow. April 2022 ended up being the coldest month on record for both Kalispell, Montana, and Salmon, Idaho. This cold ended up negatively impacting cherry orchards around Flathead Lake, as the honeybees were slow to pollinate the flowers. So they ended up with not as much cherry crop this year. It was quite an active month that started with a damaging wind event between the 4th and 5th. Gusts near 70 miles an hour caused a plethora of downed trees, power outages, and even a few snow squalls that interrupted traffic. A closed low brought heavy snow to the region with over a foot of snow in the mountains, 11th and 12th. A northeast wind brought damage to northwest Montana, also on the 11th and 12th. And another backdoor front brought sudden, gusty northeast winds on Swan Lake that caused 2 fatalities. Another closed low brought snow to southwest Montana on the 28th. It's interesting to note that Kalispell was colder than the previous record by 1.7 degrees. Salmon was 4.7 degrees colder than the previous coldest April from 2008, which was a strong La Niña. Another thing to note here is the fact that there are a lot of La Niñas in the coldest Aprils. Notice for Kalispell, which has the longer record since 1900, there are 3 back-to-back La Niñas that were also cold, 1975, 1917, and 1972. In both 1917 and 1975, the next winters went on to have 3rd La Niñas in a row. Other honorable mentions: it was the warmest July through September on record for Missoula. And it was the most active severe weather summer on record in western Montana and north central Idaho. And here's a picture of hen egg size hail that brought widespread damage to Kalispell on July 7th.